Hello guys, welcome back again to another video of your class 11 mathematics. In today's video we're gonna learn a new chapter that's nothing more than your chapter 7, which is your permutation and combination. Okay, this permutation and combination is not only important onto your class 11 and to class 12 only, okay? It's gonna be very important over here in your future life also if you're gonna opt for your uh, any competitive exam or even your IIT, JEE, anything. Okay, so try to consider it over in permutation and combination very nicely. So before we go over ahead with what is permutation and combination, let me just try to focus over here with some basic example. So suppose I give an example that uh, I got suppose I say that I have 3 pens and 2 shirts and I want to wear them. So you might be thinking 3 pens and 2 shirts, how to do it? So basic thing what can I do over is that I can illustrate with a diagram that I got 3 pens. The 3 pens can I make it into pen 1, pen 2 and your pen 3. And similarly your shirt can I make it into shirt 1 and your shirt 2. So basic thing what I can do over here is that your pen 1 I can make this pen 1 to be nothing more than I can wear your 2 shirts. So that will be your shirt 1 and your shirt 2. So in short, I'll have pant 1, shirt 1, and similarly your pant 1, your shirt 2. Now that was all for pant 1, and similarly I'll go with your pant 2. Your pant 2 again will be the same thing. That will be two things again because I got 2 shirts, so that will be nothing more than your shirt 1 and your shirt 2. So that will be your pant 2 shirt 1 and then your pant 2 shirt 2. So that's all about your pant 2. Now lastly I got pant number 3. So again same thing will happen. So that will be your shirt 1 and then your shirt 2. So that will be nothing more than your pant 3 shirt 1 and then your pant 3 and then your shirt 2. So if you can count, I have 1 2 3 4 5 6. So I'll be getting nothing more than your 6. So I can wear them nothing more than 6 ways. So this is the basic illustration. But if I happen to do this one in simple terms, I can do. So that will be I got 3 pants and I got 2 shirts. So what I have to do, I'll simply multiply. So 3 into 2 is nothing more than 6. So the answer became same. So what is this actually? This is nothing more than your, let me go again to your next page. That's nothing more than your fundamental principle of counting. So what is fundamental principle of counting? You can see your textbook, or let me just give you a definition. It's nothing more than if an event can occur in m different ways, comma, following which another event can occur in and different ways, then the total number of occurrence of the event in the given order is nothing more than your m into n. So that's your definition. So let me just again copy the example. So I got one event, so this is your m, and I got another event that's nothing more than n. So if m into n, nothing more than your 6. Okay, so that's all about your fundamental principle of counting. So along with it, let's try to do some question regarding to your exercise 7.1. Remember, you have to focus with the question very nicely first. Okay, so first question is given to be question number 1 is given that how many 3-digit number can be from the digits 1 2 3 4 5. So I got 1 2 3 4 5, and remember that I have to from nothing more than your 3-digit number. So 3-digit number, so let me just say that this is a 3-digit number. So the first one is always your ones place, the next one is always your tens, and the last one is always your hundreds. And number A, okay, number A is given to be the digits can be repeated, or repetition of digits allowed. So what can I say is that if repetition of digits is allowed, in a ones place, I can take any number from 1 till 5. So it will be 1 till 5. I can take any number. So there will be nothing more than your 5 ways. And I'll just try to assume that in a ones place, I took number 5. The same number I can take here also, right? So it will be 5. And the same number also I can take over here also, because the digits is repeated. So if this is 5 ways, similarly, this will be your 5 ways, and also this will be your 5 ways. So according to fundamental principle of counting, I simply have to multiply. So it will be 5 into 5, nothing more than your 125. And that's your answer. So if I have to give you in wordings, it will be, I can say that as we have to form a 3-digit number by, not number, but not by, I would say from the, I can say from the digits, 1 2 3 4 5 is now 1 2 3 4 5, and also the repetition of, the digit is allowed, so I can say hence by fundamental principle of counting, I give short form by FPC, at the 3-digit numbers that can be formed, which be nothing more than 5 into 5 into 5, which is nothing more than your 125 ways. So I can get into your 125 ways. So that's all about your number A. Now, let me go with the next one, number B. For number B is given to be the repetition of digits is not allowed. So again, the same example, repetition of digits is not allowed. So that's your ones place, that's your tens, and that's your hundreds. So I will give another one. So suppose from 1 till 5, it's in one place, I can take 1 till 5, a number, and then I took number 5 here again. For this question, repetition of digits is not allowed. That means this 5 cannot occur over here, right? This can't happen. So if 5 is from 1 to 5, if 5 is removed, that means it will be nothing more than 4 ways. And same thing, suppose I took number 3 over here, I cannot take number 3 over here again. So again, 3 is also removed. So if 3 is removed, there will be nothing more than your 3 ways. So in short, I'll get the answer 3 into 4 into 5, which is nothing more than 60. Right, now how to write in wordings, I can say that the above digits, that is 1 2 3 4 5, are to be taken in order to, I can say, yeah, are to be taken in order to make a 3-digit number. So as repetition of digits are not allowed by FPC, total number of ways, the 3-digit number can occur would be nothing more than 3 into 4 into 5. So it's nothing more than your 60 ways. So that's your answer. So that's all about your question number 1. So in a similar manner, let me do your next question. That's your question number 2. Your question number 2 is given that how many 3-digit even number can be from the digit 1 2 3 4 5 6 if the digit can be repeated. Remember that whenever even number comes, it means the ones place should be an even number. So I got the number here, nothing more than the 1 2 3 4 5 6, and I have to form a 3-digit even number, and digits can be repeated. Okay, so if I form 3-digit even number, so that means the ones place must be occupied by an even number. So what's the even number? 2 4 and 6. So the ones place is only possible in nothing more than your 3 ways, and the remaining would be nothing more than 6 and then 6. Why? Because they are 6 digits and the digits can be repeated. Okay, so as we have to form a 3-digit even number from the digit 1, 2, 3, 4, 5, 6. So the unit place must be filled up by even numbers, that is 2, 4, or 6 in nothing more than your 3 ways. And again the digits can be repeated, so hence by fundamental principle of counting, total number of 3-digit even number that can be from would be nothing more than 6 into 6 into 3. So I will getting the answer 636. 36 and 3 is 108 ways. So that's your answer. So that's about your question number 2. If you didn't understand, pause the video, check once again your question number 1 and also your question number 2, and then try to focus over there to the next question. Okay. So again, same thing. Let me jump again to your next question. Let me go to your question number 5. For question number 5 is given that a coin is tossed 3 times and the outcomes are recorded. How many possible outcomes are there? So whenever a coin is tossed, one coin is tossed, the outcome is always your head or tail. So it means nothing more than your 2 ways, right? So over here I can say that since for one toss of coin, the outcomes are either head or tail. So for 3 tosses of coin, according to fundamental principle of counting, total number of ways it can be done, the number of ways it can be done will be nothing more than 2 into 2 into 2, which is your 8. So that's your answer, and that's all about your question number 5. Okay, so that was all about your exercise 7.1. So let me again go to your next topic. That's nothing more than your I would say factorial notation. Your factorial notation is again very important chapter. Why? Because if you don't know factorial notation, you won't be able to do your permutation or combination in a very sweet manner. So factorial notation is always denoted by an hyphen sign. So always remember it is going to be n factorial, which will be n minus 1, n minus 2 goes until your 3. I don't know why I'm giving a bracket. Yeah, goes until 3, 2, 1. Or your n factorial will start from 1, 2, 3, goes until your n minus 2, n minus 1, and then your n. Okay, this is from big to small, and this is from small to big. Over here, most of the time, not most, I would say almost every time, I'm going to use this one. That is from big to small. Okay, so this one is all about the factorial notation. Definition, you can check your textbook. But what is actually this? Let me just try to give an example. Suppose I happen to ask you your 2 factorial. Now, according to this, that will be nothing more than the value for n I got to be 2. So 2 minus 1 is how much? Nothing more than 1. So the answer will be 2. That's all. Similarly, I happen to give 3 factorial. The answer will be 3, 2, 1, which will be 6. Now, if you can see both the example, I always end up with the number 1. Okay, so whenever factorial is there, try to end up with a number 1 all the time. Similarly, 4 factorial would be your 3. Oh, sorry, I got 4. So 4, 3, 2, 1, that's nothing more than 24. Then comes your 5 factorials, that is your 5, 4, 3, 2, 1, which is your 120. And then comes your 6 factorial, that will be 6, 5, 4, 3, 2, 1. That will be nothing more than your 720. Okay, and why I'm giving you this example is that because I want you to memorize this one, so that whenever we do sum and I happen to ask what is 4 factorial, instead of doing this manner, your answer will be directly 24. Okay, I want that manner. So that is how to be done your factorial notation. So let's try to do some questions over here from the factorial notation. So your question number 1 is given to be your 1 sorry, 1 exercise 7.2. Your question 1 is given to be nothing more than your 8 factorial. So what is actually 8 factorial would be nothing more than your 8, 7, 6, 5, 4, 3, 2, 1. Or what can I do over here is that I can say 8, 7 and then 6 factorial. I can just stop over here. So that will be 8, 7 into, I got 6 factorial to be your 720. Okay, you can do both of it also, but always try to do in simple manner. Why? Because I already know 6 factorial. The value for 6 factorial is nothing more than 720. So that once I try to multiply this, and if I happen to try to multiply this, I'll be getting the answer. Wait for a minute, let me just multiply, and I'll getting the answer nothing more than your 40 to your 320. So that's your answer. Similarly, number 2 is given to be your 4 factorial minus your 3 factorial. Now let me go back again. Your 4 factorial I got it to be 24, and your 3 factorial I got to be 6. I'll just simply put the value. So it'll be 24 minus 6, so that's nothing more than your 18. So that's your answer again. So I got question number 1 and question number 1 2. So in similar manner, pause the video and then check nicely. So let me go with your question number 2 again. Your question number 2 is given that is 3 factorial plus your 4 factorial is equal to your 7 factorial. So let me take on the left hand side. Your left hand side I got to be your 3 factorial plus your 4 factorials. That's nothing more than 6 plus 24, I got to be 30. And similarly, your right hand side, I got it to be your 7 factorial. 7 factorial, I don't know what 7 factorial, but I know 7 into 6 factorial. So which is 7 into your 720. So if I do that, I'll get the answer 5040. Now see, left hand side and the right hand side doesn't match. So therefore, left hand side not equal to your right hand side. That is 3 factorial plus your 4 factorial is not equal to your 7 factorial. Okay, so that's about your question number 2. You can pause the video and check nicely. Let me do your question number 3 again. Your question number 3 is given that compute your 8 factorial divided with 6 factorial into your 2 factorial. Now, a different part about this question is that in question number 1 and question number 2, there was no denominator. Here I got the denominator, and for this the denominator also, very good thing is that I got 2. So always see which one is greater. Over here the greater thing is your 6 factorial. So what you have to do is that factorize 8 until you get 6. So that will be 8, 7, 6. So stop it over there. Then I got here 6 factorial, then I got 2 factorial. So make it 2 into 1. What can do? 6 factorial and then 6 factorial cancel. 2, 4. The answer is your 28. So that was your question number 3. Now, again in the same manner, let me do question number 4. Your question number 4 is given that if your 1 by 6 factorial plus 1 by 7 factorial is equal to x by 8 factorial, the value question says find the value for x. Now again the same thing, compare your left hand side and your right hand side. If you can see in the left hand side and the right hand side, I got division, and good or funny thing is that the lowest term over here is your 6 factorial. So what can I do? The next thing is that I can make this one to be 6 factorial. 7 factorial I can factorize until I got 6, and similarly 8 I can factorize until I got 6. Now if I do it, what can I do? I can simply cancel 6, 6 and then 6. So that your answer, I'll just do it over here. So that your answer would be 1 plus 1 by 7 is equal to x divided by 8 into 7. So that will be, if I take the LCM, that will be 8 by 7 is equal to x divided by 8 into 7. I can cancel 7, 7. So the answer of x would be nothing more than your 64. And that's the answer. Alright, so again same thing, pause the video and then check nicely.